Hello and welcome to my video. In this week, I am uploading some problems related to polynomials, especially polynomial divisions. So please check the link at the top right corner to watch the polynomial videos I've already uploaded. And let us take a look at today's problem. It says, prove that if x squared plus 1 divides the polynomial px squared, then x squared plus 1 also divides the polynomial px. We can write this statement like this. This means that x squared plus 1 divides px squared. Then we have to prove that x squared plus 1 divides px. I mean, the other way around is pretty obvious. But how can we prove this? Like many problems regarding polynomial divisions, we have to use the basic properties of division. If a divided by b gives quotient q and remainder r, we can write a equals bq plus r. So here let qx be the quotient for division of px by x squared plus 1. Since px is divided by quadratic polynomial, the remainder must be linear polynomial. Let ax plus b be that remainder. Then if we write in this form, we have px equals x squared plus 1 times quotient qx plus remainder ax plus b. Now we want to show that px is divisible by x squared plus 1, so we want to show that a and b are both zeros. And in order to do so, we have to use the fact that x squared plus 1 divides px squared. So if we square both sides, we have px squared on the left hand side, and on the right hand side, let's use this formula. So we have x squared plus 1 squared qx squared plus 2 times x squared plus 1 qx ax plus b plus ax plus b squared. So we have x squared plus 1 here and x squared plus 1 here. So these two terms are obviously divisible by x squared plus 1. Therefore, if x squared plus 1 divides px squared, then x squared plus 1 must divide this part ax plus b squared. So we have this condition, meaning that this ax plus b squared equals x squared plus 1 times some quotient q2x with 0 remainder. But since ax plus b squared is a quadratic polynomial with leading coefficient a squared, we can write ax plus b squared equals a squared times x squared plus 1. Meaning that this quotient q2 is simply a squared. Expanding both sides gives a squared x squared plus 2abx plus b squared equals a squared x squared plus a squared. If we compare the coefficient of x, we have 2ab equals 0. And if we compare the constant terms, we have b squared equals a squared. Here, this first equation means either a is 0 or b is 0. But if a equals 0, then this second equation gives b equals 0. And if b equals 0, then the second equation gives a equals 0. So either way, we have both a and b are 0. This means that from our first equation here, we have px equals x squared plus 1 times qx. Therefore, x squared plus 1 divides px, and hence the proof is complete. And that was all for this video. Thank you for watching, and I will see you in another video.